This video we will solve further problems from exercise 1.3. Question number 10. If f and g are functions from real value to real value and is defined by f of x is equal to absolute value of x plus x and g of x is equal to absolute value of x minus x, then find g composite function with f and f with g. So let's first define what's given. So given to us f of x is equal to mod x plus x. So this would imply that our f of x is equal to 0 if x is less than or equal to 0, and it's 2x if x is greater than 0. How can we prove this? So let's prove this here. So f of x is equal to mod x plus x. So let x equal to minus 1, which is less than 0. So now our f of minus 1 is equal to mod of minus 1 plus minus 1. That's equal to mod of minus 1 is 1, plus into minus is a minus, so that's equal to 0. So when it's less than or equal to 0, the value of x, it becomes 0. Now let x is equal to 2, which is greater than 0. Then our f of 2 will be equal to mod of 2 plus 2, which is 2 plus 2, that's 4, which is 2 times 2. Therefore, it's 2x, right? So similarly, we can define our g of x to be equal to, which is mod x minus x is defined as g of x is equal to, let's first consider, let x is equal to minus 1. Then our g of x is equal to minus 1 mod minus of minus 1. That's equal to 1 plus 1. That's equal to 2, or you can say 2 times 1, which is 2x. And if our x equal to a positive 1, then our g of x is going to be equal to mod 1 plus 1 minus 1. So that's equal to 1 minus 1, that's equal to 0. Therefore, it is 2x if x is less than 0, and it's 0 if x is greater than or equal to 0. So now we can have three different scenarios looking at the intervals here, class intervals. So let's say three scenarios: 1, x less than 0, then b, x equal to 0, and c, x greater than 0. So let's first take the first scenario where x is less than 0. So our f dot g of x is equal to, when x is less than 0, your g of x is 2x. So it is f of 2 of x. Now f2 of x, let's consider, since x is less than 0, we have to take the first condition, and in the first condition it says that it's equal to 0. So that's equal to 0. Now in the second condition, f g of x is equal to, when x is equal to 0, your g of x is 0. So it's f of 0, and f of 0, x is equal to 0, would be again 0. So in the first two conditions, you see that it's equal to 0. Now let's take the last condition where x is greater than 0. So when x is greater than 0, g of x, so f of our g of x is, when x is greater than 0, it is 0. Therefore, again, this will be also 2x, so it's 0. Now, we can therefore f of g of x is equal to 0. Second, let's work out g of f of x, again for the three different conditions. So g of, when x is less than 0, your f of x is going to be 0. So this is 0, that will be equal to 0. Then your g of f of x, when x is equal to 0, again it is 0, so it's 0. Then your g of f of x, when x is greater than 0, so f of x greater than 0 is 2x, so g of 2x. However, when you come to g of x, when it's greater than 0, it's a 0, so this is equal to 0. Therefore, g of f of x is equal to 0. Question number 11. If f, g, h are real valued functions defined on R, then prove that f plus g composite function with h is equal to f with h plus g with h. What can you say about f composite with g plus h? Justify your answer. So let's first prove. So to prove f plus g composite with h is equal to plus g composite with h. So let's take the left hand side. So the left hand side is f plus g composite with h. So this we can say equals f composite with h of x plus g with h of x, since f plus g of x is equal to f of x plus g of x. So that's nothing but f composite with h plus g with h, and that's equal to right hand side, hence the proof. Now regarding f of g plus h, again we can say this is f of g plus f of h, since f, g and h are all real valued functions. Therefore, f of g plus h is also a function. Question number 12. If f is a function from real value to real value and is defined by f of x is equal to 3x minus 5, prove that f is bijunction and find its inverse. So what's given to us is f of x is equal to 3x minus 5, and f is a function from real values to real values, right? Now, to prove that f is bijunction, the condition that was given is, first find the inverse of f. So let f inverse be defined as g. Similarly, find g inverse and if. So step 1, find f inverse and call it g. Then find g inverse. Then if f composite with g is equal to I, y, and g composite with f is equal to ix, which is, this is an identity function with y and it's an identity function with x. If this condition is satisfied, then f is a bijection function. So let's try and follow the steps. So first let's find the inverse. To find the inverse, so let's call y is equal to, let y equals 3x minus 5. So this implies that our 3x is equal to y plus 5. That implies that our x is equal to y plus 5 divided by 3. Therefore, g of y, which is our inverse function, will be equal to y plus 5 divided by 3. So we now have f and its inverse function, which is g of y. So let's find f of g of x, y. So that's now equal to f of y plus 5 divided by 3. So let's substitute this in f of x. So this is f of, 3 times y plus 5 divided by 3 minus 5. So here 3 and 3 will be cancelled. So you're left with y plus 5 minus 5, which is equal to y. So we can clearly see that our f of g is identity function with y. Similarly, let's do g of f of x. So that's equal to g of f of x is 3x minus 5. So substituting that in g of y, you will have 3x minus 5 plus 5 divided by 3. 5 and 5 will be cancelled. So you have 3x by 3. Again, 3 cancel is equal to x. Therefore, our g of f is equal to identity function with x. Therefore, f and g are bijection functions, and they are inverse to each other, and the inverse function f inverse of y is defined by y plus 5 divided by 3. Further, replacing y by x, we can say f inverse of x is equal to x plus 5 divided by 3. Question number 13. The weight of the muscles of a man is a function of his body weight x and can be expressed as weight of x as a variable is equal to 0.35x. Determine the domain of this function. So given to us, given w of x is equal to 0.35x, where W of x is the weight of muscles, is the weight of muscles of a man with body weight x. Okay, now if you're going to sketch this graph with x-axis as the body weight and the y-axis as the weight of muscle, now we do not know what's the smallest value that x can take. This starts from 0, but we certainly know that x cannot be negative. It has to be a positive number. So we can call it, from 0 it starts. Cannot be 0, of course, above 0. And again, we cannot define what's the maximum value, the maximum weight of a person. So we're going to consider this in the range which is 0 to infinity, and we know that it's an increasing function. As x increases, the weight also will increase. So it's an increasing function. Therefore, the body weight is always positive, and the function Wx is an increasing function. So we can define the domain as, so the domain is from 0 to infinity, since x is greater than 0.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.